Hi everyone, and welcome to the first webinar in our mini-series, Moving to the Cloud with Google Cloud Search. Everyone has been muted to eliminate any background noise, and if you have any questions during today's presentation, please feel free to type them into the Q&A box on your screen and we will cover those questions at the end. Now I'd like to introduce our speaker. Bill Fowler is a search architect with over 20 years of experience in enterprise search. His product experience includes Google Cloud Search, Azure Search, Elasticsearch, and Solr. He has integrated search into environments and products including SharePoint, Drupal, Adobe Experience Manager, and Salesforce.com. His experience includes each stage of search engine implementation, including project definition, content acquisition and preparation and indexing, security, and relevancy tuning. Bill currently serves as a functional and industry analytics manager for the Search and Content Analytics Group within Accenture Applied Intelligence. And now I'll pass it over to you, Bill.
Thanks. As Suzanne mentioned, I'm Bill Fowler. I'm a search architect and manager in the Search and Content Analytics Group at Accenture. Much of my experience comes from working with a company called Search Technologies, where we specialize in implementing enterprise search and later in big data and machine learning applications developed to drive search analytics and improving search effectiveness. We were acquired by Accenture about a year and a half ago, and our company was combined with Accenture's data science, analytics, and AI groups to create the Search and Analytics Group itself. One thing I've never forgotten is that 80% of the enterprise data that we see is unstructured data, and this is a our core competence in enterprise search is understanding how to manage, search, and derive analytics from unstructured content. And this helps us allows us to help clients create a great search experience. Search Technology actually was a relatively small company, but we were global in our scope, and we actually did have 800 plus customers in enterprise search and later in big data and machine learning applications. And our services, you can see here that are really a soup to nuts, from assessment through managed services in the area of enterprise search. And in our offerings, I just want to highlight a few of those that I've been involved with, including intelligent enterprise search, e-commerce search, and especially in implementing data lake-based search for pharma industries and financial services. But we're really here today to talk about Google Search in the cloud. And I just want to start off with just a comment about things that we all know and understand about the cloud, and that is that, and I want to just highlight the fact that people are attracted, like you are here today, because of some compelling nature of search in the cloud, and that is it lowers costs and you can outsource system management, and those are the two #1 reasons we hear constantly about why people want to migrate to the cloud. But there are other benefits to it as well. And specifically, our experience is that cloud search as an application in the cloud really is gaining traction. Every one of our customers who comes to us and asks help for migrating to a new search engine or creating a brand new search application ask about how to implement in the cloud, and there's some compelling reasons for this, and we have a lot of experience in providing this kind of transition to our customers moving to the cloud. The most interesting thing about it, I think, is that cloud-based services are often the best mechanism to apply big data machine learning analytics to the process of enterprise search, and this is now all built into Google's Cloud Search product, and so we're going to talk about that and as a very important component. So I want to talk about, having talked about it in general, I want to kind of drill down and say some specific things about how the Google Cloud Search developed. So it was originally developed as an add-in feature to G Suite. And in that process, it did not, it actually concentrated on the enterprise repositories within G Suite, which included Calendar, G Drive, Gmail, Google Groups, and Google Sites. And it also integrated Google's world-class security solution that it had in place within G Suite and developed mechanisms by which we could leverage that for enterprise search. And of course, has built-in analytics as well. So about a few months ago, Google released its version of Google Cloud Search as a standalone service, and by that I mean service available to customers who are not G Suite customers. And in order to do that, of course, it had to address the issues of, well, how do you get content from third-party content sources like SharePoint, for example, and how do you get that into the Google Cloud Search for indexing purposes? And they did this by, well, the other thing is, of course, that they had to account for security as well. So those are two issues that they addressed. In terms of getting new content sources, third-party content sources into the cloud, they developed connectors based upon a connector framework they developed for such purposes. And that also allowed third parties to develop data source connectors, as we at Accenture have done, and actually to utilize our current connector product line to make them available to Google Cloud Search. And so we do provide connectors for SharePoint, Confluence, AEM, Salesforce, and many others. The other aspect of it, as I mentioned, is that Google had to address the issue of enterprise security. And so this is a very important idea that all searches within Google Cloud Search require authentication. And so Google understood that, in fact, authentication has to match up to third-party content sources as well. So typically they are Active Directory or LDAP or similar kind of authentication directory repositories. And so they developed a synchronization method by which you can synchronize your Active Directory or LDAP identity sources and synchronize them into Google's identity source. And Google's identity sources, as I mentioned, is also utilized across all other, a lot of other Google products in the cloud as well. So the upshot of it is that because the content source ACLs are honored for authorization, and I'll talk a little bit about that later, this gives you document level security. And so from a security standpoint, there's a world-class security solution that takes your directory services, your users and groups, and also indexes for authentication purposes, and also indexes ACLs for authorization purposes. So there's a complete and comprehensive solution for security that gives you document level security. And from the standpoint of user experience, you can develop a user experience for Google Cloud Search that's completely independent of G Suite. So your users don't have to log into G Suite, or they don't have to have a G Suite account or anything like that. And you can develop a user experience as you would any other standalone enterprise search application in the cloud or on premises, doesn't matter. The Google Cloud Search has query and API listing APIs, and I'll talk about that in a bit. And as with modern search engines, the JSON, the responses are actually in JSON. So I want to then complete this sort of abstract of what Google Cloud Search is by this chart here. So you see the component in yellow that's identified as G Suite, and that's the original version of Google Cloud Search. And you see the 5 content sources that are supported and directly indexed. into Google Cloud Search, as well as a Google Identities component that provided search for that. So even though you don't have to be a G Suite customer to utilize the new enterprise search version of Google Cloud Search, you can be a G Suite, and this means also you can integrate search with the Google G Suite application repositories, Calendar, G Drive, and that kind of thing, with enterprise sources. So on the left, you have the enterprise source content that has two components. Obviously, we need an identity source to enforce the required authentication for doing searching within the Google Cloud Search, and that provides the mechanism by which authorization can take place when ACLs are indexed. But you also have the standard Google, I should say, the standard content sources that are from the third party and are indexed by a content connector. So one of the fundamental features of the aspects of Google Cloud Search is the idea of a search application. And actually, Google defines a search application as something that gets configured within the context of Google Cloud Search. But really, it's more. It kind of seems to be more than that. A search application allows you to configure multiple content sources, some of which can be, or all of which can be actually external to Google outside of G Suite. And you can kind of think of a search application as a quote-unquote single search index, although how that actually works out, it's not really addressed by Google. But you just think of it as a way you can do searches across multiple content sources, which is the fundamental requirement of enterprise search. And connectors push the data into the index by an indexing API. And there's also APIs available to develop the search user experience. Search applications can be seamless and transparent. And by that I mean simply that you don't have to log into G Suite or be a G Suite customer. And you can embed your Google Cloud Search application into your website, whether it's site search or intranet search and that kind of thing. For the most part, and the search applications themselves and the number of data sources are subject to licensing, so you should be aware about that. Has to do with how this gets priced and so forth. So let's talk a little bit about the indexing features and how to get content into Google Cloud Search. When I talk about the indexing architecture right now, I want to talk about the schema that is required to go into the Google Cloud Search. And the schema really consists of three components, something I call special objects. And these are Google-generated fields that exist within the index, and they're mostly used for internal use. For example, there's an internal ID that is used and that sort of thing. There's the structured data. This is what we normally think of when we talk about document metadata. So, for example, PDFs allow you to extract title and author and so forth. And so that would be structured data in the way that Google Cloud Search talks about specific kinds of content. And then there's the item metadata. So we know that fundamental to Cloud Search, or I should say to enterprise search, is the idea that there are multiple content repositories. And so this item metadata are common fields across all of those content sources. So let's drill down and talk a little bit more about those in detail. So the special objects that I referred to include item name. So there's a special Google item name that may or may not be used in this case in terms of the ultimate user interface or the way that the search actually works. There's something called item content. And what's interesting about this, and I just want to make a special note about this, is that when you develop a schema for Google Cloud Search, all of the document that you want indexed goes into a separate item content element. And this is actually important for performance purposes because the actual item content element can be separated from processing the rest of the document. And I'll go in a little bit of detail about that, but that's useful for performance purposes. And logically, it's useful as well. There's ACLs as part of the special objects, so that provides for document level security. You find out what version of the document exists, and that's internally generated, as is item status. And I am just going to mention here that what is supported is a document hierarchy. So you can have a parent document, and those are connected by an ID to child documents that are related, and that is signaled by this document type in the special object section of the schema. The structured data, as I said, is data that comes from the document itself, what we normally think of document metadata. This is the piece that is most often customized by admins. It's completely customizable in the same way that indexing schemas for other search engines do. Of course, there are fields and there are field types, therefore, and the field types that are supported are the usual suspects: text, HTML, integer, double, Boolean search, Boolean fields, two date fields, timestamp and date itself, and then objects, and there are certain objects that are available within each of the categories of the schema, and enumerated elements as well. So again, as I said, item metadata refers to items or metadata that applies to all document repositories that are indexed. And so these are the common fields, and they include title, MIME type, URL, language, creation date. There are a few other things that are supplied by Google. One is search quality. So one of the interesting features of indexing with Google Cloud Search is that there is a data quality measure that it determines the potential importance of a field to specific queries. There's object types that you can use as a filter. Keywords, you can extract keywords and apply them. Container and update date. And so those are all available for cross-repository search. As far as the actual indexing mechanisms go, so most likely you will index content through connectors. But at a more fundamental level, there's a REST API that's JSON-based to push content from your repository, your external from Google repository, into the Google Cloud Search Index. There's a Java client library, but also you can generate and utilize other languages, including, say, Python, C#, and those kinds of languages, .NET, and so forth. So you can absolutely develop your indexing mechanism the way you want it using the tools you're familiar with and that sort of thing. And there is a connector SDK as well. And so the SDK is useful, again, if you're creating a custom connector. But for the most part, I think even now there are numerous connectors that are available for specific external document repositories, and I want to talk a little bit about that right now. So Google itself, based upon its connector framework, has developed quite a few connectors, and these are the kind of top ones, which is a CSV, comma separated value document connector, JDBC for database applications. There's a web crawler, including one for Nutch. There are 3 versions of SharePoint, including hosted SharePoint, and a complete list of these is available at the URL, and there are quite a few. I think there's something like 80 different connectors. Now, some of those connectors are third-party, including Accenture's third-party connector. So Accenture has, for a number of years, and especially when we were at Search Technologies, developed a technology that we call Aspire, and that has a connector framework built into it as well. The consequence of that is that we've built over 30 connectors to content sources, and we've added a publishing element, which is the way we push content that we've connected to, processed, and pushed into a search engine, and we developed a special one for Google Search. So right now, even if you said, I want to start this new search application with Google Cloud Search right now, there's probably, at least even just from Accenture, 30 different connectors for specific content sources. These are ones that I've worked with recently: Confluence, AEM, ServiceNow, and Salesforce. But there are a bunch of others, and you can see which ones are available at our website. Really from a data standpoint and supporting third-party sources, there is a very, very comprehensive library of connectors that you can use right now for a cloud search application. So if we look at indexing from a document content standpoint, I want to get back to that idea of, in the schema, defining the content to be indexed, that element. And so typically what happens is that, as you might imagine, there's an indexing queue, and it goes through kind of, field by field and indexes it, and that's all well, and especially works well if the documents themselves are not very big. And Google knows from its extensive experience in enterprise search with the Google Search Appliance how big documents are and what the performance implications are as well. So if the document is not really very large, let's say under 100K, then it will just be indexed in line, and that's that. However, if the content element is very large, and this often happens even with large PDFs, but maybe other content types as well, is that if it's over 100K, you can configure the indexer to separate the processing and have a separate upload for those fields those content fields that are very, very large, and this will optimize the indexing process. Google indexes text and raw content, so actually it will do text extraction from raw content, binary content, and it also does language content, I should say language detection as well. Oh, and there's one other thing that's very interesting and a very powerful feature we have found for complex search problems is the ability to create a hierarchical relationship amongst documents. And so this is a very, very useful feature. And this is fully supported by the Google Cloud Search. And it has features like, if you delete the parent, the children will be deleted as well. And this is actually separate from HCLs, I should say ACLs, and ACL inheritance. So let's now move from indexing to query and security. So we know the core requirement of enterprise search is to combine results from many different sources, and in this context, external sources as well as Google products. And so when you do a search and your search application has defined multiple external content sources as well as possibly G Suite content repositories, search, if it's so configured, and typically it is, search results will come from all of those sources, and they will be ranked accordingly as well, and it's possible to boost based on content source as well. So that's sort of the essence of enterprise search. Google supplies an embeddable search widget, which you can kind of create prototype user interfaces that include all of the search features. It's not necessarily something you would use in production, but it does make it a little simpler to do Q&A and demonstrations, whereas otherwise you would be using JSON and Postman or something along that line. The features are typical search features, the important search features. There's faceting, filtering, sorting, pagination, and it does compute snippets as well. For auto-suggest, this is a really interesting feature within Google Cloud Search. So you can specify in your auto-suggest that it is restricted to people, or restricted to query history, or content, or combinations of all of those. Some of these we found are not necessarily have been released yet, but I believe that functionality is imminent. And finally, there's an interesting listing API, and this gives you the ability to view all of the index data and all the components within each of the content items. So you can view ACLs, the version of the document, the index state, if there's errors, and that sort of thing. And so this is very, very useful in context of a Q&A. Let's talk a little bit more about security. So authentication search is available only in authenticated sessions. So this is important, and you might think, well, does that mean I can't do site search, for example, which typically doesn't have an authentication requirement? So what I will say about that is that we have had experience developing search applications in which service accounts are used to create an authenticated session. And so that's conceivably possible for what you would do. I wouldn't think that it's a mainstream application for Google Cloud Search, but I don't think there's anything that would prevent that. Single sign-on is supported, and the default authentication method is OAuth 2, and SAML is also a possibility for implementation. For external content, as I've sort of described in very limited detail, there's the idea of an identity source. So we know that Google has its own Google identity source, and that is internal to G Suite. And then there's the identity source which Google defines as an external collection of users and groups. And so we know that that would be your Active Directory or LDAP or third-party tools from IBM, for example, or Oracle. And all of those can be used as identity sources, these external sources, collections of users and groups. So typically what would happen is that you would use an application called Google Cloud Directory Sync, and that syncs your LDAP to the cloud identity, to Google's cloud identity, and that's how users and groups get implemented in the search context. Now, it may be that your particular directory service, if it's homegrown or something like that, is not supported. Then you could use the identity API to create that synchronization function. There's also a cloud identity connector SDK, so you could actually build a full-blown connector that maintains that synchronization. So there you have a lot of options, and including the simplest one is using the Google Cloud Directory Sync tool. So the other piece of security other than authentication is, of course, authorization. And as we've talked about, document ACLs are indexed as a special object, and hence they are automatically filtered in exactly the way that you would expect to happen in an enterprise search application, and that gives you document level security. And we do have Google Cloud Search does have a group expansion as well. So it covers all of the bases to meet the requirements of enterprise search. Search accuracy. So we know that Google has a lot of experience in determining the relevance of documents, and in terms of what I would refer to as big Google, the Google search appliance, and so on. One of the things that we know about Google is that they don't say much about how relevancy works specifically, and there's usually not a lot of control that you have over customizing the relevancy calculations. But there are some that are very important, and at index time you can determine that document freshness, the importance of certain text fields, and search quality metadata will factor into it to whatever extent you would like to see that affect the relevancy. At query time, you can enable those boosts as in terms of the freshness, personalization, which I'm going to talk about in a second, and boosting by content source. So you can basically toggle those on and off. Personalization is one of the most interesting features of the Google Cloud Search, and it uses queries, interaction history, and the cloud identity, extracting data for user content to affect the ranking of the search results. So this is a case where Google is using its AI and machine learning capability to affect the ranking of content. So the ranking of content and the relevance of the search results will be excellent out of the box. And so this is a real challenge in the implementation of other search engines that don't have features like this. You do testing and you figure out some problems with how the search results are going, and you have to solve the problems, and maybe you go through iterations. I believe that with Google Cloud Search, because they have this personalization aspect, out of the box, you will have a superior search experience with regard to the relevancy of content that gets returned. They also more specifically have popularity ranking, and in my experience, which is pretty extensive with the Google Search Appliance, popularity ranking was a very popular feature when it was implemented, and so that really is based on the number of clicks a document has over time, so that sort of hints that that document is very relevant to a wide range of queries and so forth. So that's it. And then, of course, page ranking, which Google is very well known for, and everybody understands that in a enterprise context that maybe there isn't those kinds of connections the way it is on the internet, but it still could be an important way of evaluating the content. So overall, I think that search accuracy is really one of the great features of Google Cloud Search, and something that doesn't really have a match in many of the other search engines and so forth. So that really kind of describes all of the elements, I think, in Google Cloud Search. So I would like to open the floor to questions that you may have. We have some questions here. So Suzanne, do you want to do this, or
Sure.
I'll just read through? But go ahead, why don't you?
Okay, sure. So the first question is, do you have any additional insight into Google's plans for integrating their entire portfolio into GCS?
Their portfolio, meaning?
For example, Google Plus.
So I don't have any additional information about that specifically. So that's a great question, because there's, Google does have a lot of repositories potentially for that. But with regard to specific Google products, I don't have any specific information. I think that that would be a question also for your Google rep.
Okay. The next question is, does the item content object have a size limit? For example, a PDF that's 2,000 pages long, including tables of data and images.
Yeah, so I believe that the only restriction, I believe there is a restriction. I can't recall what that size is, but Google does account for larger PDF style files, which would be over 100K, and those get processed separately. So they do kind of address the issue of very large content items.
Okay. Do we need to subscribe to the connectors that Accenture built, or do we just license them one at a time? Also, how often do you need to make changes or enhancements to the connectors?
So those are two good questions. So there are various ways that you can acquire Accenture connectors, and so there's licensing models for just for determining the way they get used as well. So our connector framework is based on Aspire, which has a content processing component as well. In fact, it's primarily a content processing system. So that's a kind of a complicated question about how you can acquire that. So under some scenarios, you can just acquire the connector, and other scenarios you'd have add-ons. So that's a sort of a more complicated question and frankly, I'm not a business guy, so I can't address specifically how they do, how they are specifically licensed. So I'd recommend talking to your account rep within Accenture for details, for those details.
Okay, the next is, my problem is crawling the content of single-page applications that don't have any text to crawl. On the internet, those sites will often expose another crawlable interface for Google. It's tough to get internal apps to do the same. Are there any connectors that would help there?
So I think that one of the pieces that we really supply value add, we meaning Accenture, to this whole to the Google Cloud Search product is our ability to do content transformations through our Aspire content processing system. And so the way that would work is that you would acquire the single page content or whatever content, and built into Aspire are mechanisms built around a document processing pipeline that you can apply Groovy scripting and all sorts of mechanisms by which you can transform the your incoming content into something that can be utilized with search. So I'm pretty confident that in that context you can acquire the content through an Accenture connector and then process that content in a way that is difficult for connectors to do, right? So oftentimes, and there are many different kind of use cases that require content processing, and so Accenture has that piece of the puzzle that we apply, and that's called Aspire. So I think in those specific use cases where you have problematical documents, very complicated documents that for whatever reason kind of really need to be transformed into the required schema element, that's, I think, the approach that you would take.
Okay. Could you elaborate on the document hierarchy? Is that something that is only applied during load into index or also extracted from the document organization in a source system?
Again, I think that that from the standpoint of Google Cloud Search, it will index what you have in terms of a content hierarchy and how you've defined it in the schema. So how that arrives there would be addressed by content processing. Again, I would go back to the Aspire product and the way that you would make that work and present the Google indexer to utilize the document hierarchy. I think you would use content processing for that.
How can it handle document level security from third-party sources? For example, SharePoint, where it usually is difficult to extract who has access to what.
Right. So this is the piece that you have an identity source, and so in SharePoint, you would utilize its identity source. And I know there's complexities, but just to say, well, can you utilize your Active Directory, and does that contain the required information that you need for permissions, user group permissions, and things like that. And if not, I think that then you would start looking at doing some customization for the identity connector, maybe create an identity connector. So I think in context, sort of without a context, you could say, yeah, the tools are there to develop very specific content, I should say identity connectors, and having the ability to synchronize those. The details of which I think, we would need to elaborate on the specific use cases and the specific problems you're facing. And we certainly have had experience in complex directory service directories and permissions and things like that. So we could help you, work through those issues.
Okay, we have time for just a handful more. So does it search from ERP systems, for example, SAP and SAP PLM?
So when I just looked at the list of connectors, and I didn't see, the only SAP one that I've seen is for HANA, and but that doesn't mean that they're not. So I would just recommend that you would look through the list. It's a very long list, and it seems pretty comprehensive. So I just direct you to that URL.
And then the next question is, do any Aspire connectors have the ability to process dynamically generated HTML, for example, WordPress generated web pages?
Yeah, again, I get back to the content processing. So we've been very successful in almost all search contexts in taking incoming complex documents and things that have special requirements to meet the schema requirements of a search engine. So I would say that kind of thing that would be perfect for implementing Aspire. So you would have the Aspire connector, and it would either crawl the content or connect directly to it if it had that content source, and then you would process the content through the content processor to make it, to transform those elements into the schema required by, or you designed for Google Cloud Search.
Okay, and the last question is, when it comes to searching ERPs, how do you recognize schema?
So the schema element you define, and you develop the schema and apply it to the cloud search application, and then it's your responsibility, so to speak, to push content in that matches that schema. And so again, it gets back to if content processing is required, then that is kind of external to Google Cloud Search per se, but we have a product that actually does that. That's Aspire, and it does it very effectively. So I think that's how you would address those use cases.
Okay, great. Well, we are out of time, so I'd like to thank everybody for the questions and for Bill for the great presentation. And just so everybody knows, we will be sending out a copy of the on-demand webinar within the next few days, so check your email for that, and you can share it with any colleagues or rewatch it if you would like. And that's all, so thank you for joining. Have a good day.